The Astrolabe. The given translation is star taker. It belongs more to the field of astrology, the world of constellations and zodiac signs, rather than astronomy, which is the study of the stars themselves. An early version of the astrolabe was invented by the Greeks between 220 and 150 BC, and often attributed to Hipparchus. Its use declined somewhat in the 17th century with the invention of telescopes, but was still being made in the Arabian world up until the 19th century. The astrolabe was a marriage between a planisphere and a diopter, and is considered to be the earliest analog computer capable of solving many astronomical problems. To say it can solve many problems is perhaps an understatement. In the 10th century, Umar ad-Suf wrote a detailed treatise of some 386 chapters describing 1,000 uses of the astrolabe, and Geoffrey Chaucer wrote a treatise in about 1350 to enable his 10-year-old son to understand, use and make an astrolabe. What can it do? Well, it can tell the time during the day or the night. It can find time of sunrise or sunset, the length of a day. It can locate celestial bodies in the sky. It can measure latitude. Islamic prayer times are determined astronomically, and the astrolabe can determine these required times. And it can find the direction of Mecca, just to mention a few. So with a series of diagrams, let's see if I can explain how the astrolabe goes together. This is the back. Now this portion here is measured in degrees. That portion, that quadrant, is 0 to 90, which is what we will use to measure latitude later. This ring here, the zodiac ring, this is to do with constellations of the stars. This portion here is to do with civil engineering and measuring of buildings and such, and the red ring is actually the track of the sun through the sky. If we turn it over, this is the front. This consists of a throne, which is the circle around the outside, and the hanging piece at the top. The blank piece in the middle is called the mater. Into this goes the tympanium. That's the bit with all the circles on. Now, to try and explain this little bit, there's a couple of diagrams. The markings on the tympanium are a stereographic representation of the enormous hemisphere. In the right hand picture there, if you take the grid of the northern hemisphere and flatten it, that's what you get on the bottom picture. So now you can see here you've got the Tropic of Cancer, the equator, and the Tropic of Capricorn. This line here is the horizon. So anything above that we can see, and anything below that we can't. This is a print of a tympanium from the period. As you can see, it's all in Arabic. On top of this goes what's called a REIT. That's, in this case, the gold brass coloured piece with all the spiky fingers on. Those points correspond with stars. The circular one in the middle, the bigger circular one, shows the track of the sun. So if we put everything together, it starts to look like this. The only thing that's missing from this is the rotating bar, which on this side is called the rule. So to come back to our version of the astrolabe, here we have the Adelaide, and on here, as you see in this quadrant, I've marked out 10-degree angles. So we would have 0 here, which is the horizon, and we would have 90 here, which is the pole. This line of dots here is used to work out the direction of Mecca for the Arabic prayer times. We turn it over to the clever side of this one. This is the rule. Underneath is the REIT with all its markings for its stars. This particular hole here is the sun, and this will show its path through the sky. And then we have time on the outside. This one's a little bit difficult to do in the small confines, but we can measure height. So imagine that the spoon is a tree, and I need to know the height. What I would do is set the Adelaide to 45 degrees, and then sight the top of the tree to where I'm standing. I would then measure from where I'm standing to the base of the tree and use those figures for calculation. So what I would need to know is the distance from where I'm standing to the base of the tree and the height of the Adelaide above the ground when the measurement was taken. Those two measurements added together will give me the height. This, of course, is not an accurate mathematical measurement. Things always move on, for better or for worse. This is a Mariners Astrolabe from Europe from about 1570. As you can see, it's a stripped-down version of the older type Astrolabe. I guess navigators did not need all the clever stuff. This one only measures the angle of the sun above the horizon. As said before, the Astrolabe can measure latitude. This is the angle of the sun above the horizon. This measurement will be taken at noon, which is when the sun is at its highest point, known as the zenith. To do, we would hold by the ring in the vertical mode, and we would line the sun through these two notches so that we could measure the angle. Obviously, looking directly into the sun is a bit of a dodgy business, so you would allow the sun to come through the two notches and you would align them on a piece of paper or something, or even the back of your hand. When you've done that, you would measure the angle above the horizon. The Earth spins on its vertical axis, but it does not remain straight. It wobbles. This wobble is known as declination. The North Pole tilts about 23.5 degrees towards the sun in the summer and away by 23.5 degrees in the winter. Maybe with this little toy I can explain this. As you see here, the Earth is tilted towards the sun. But as we pass through the seasons towards winter, as we get round to winter, midwinter, you see now that the Earth is pointing away. That is declination. This change in declination over the months of the year is something that the ancients have observed and measured for years, and they wrote them down. These records are in a book called an Almanac. There are loads of astronomical measurements and observations in this book, which is why all navigators have one. Here are a few examples of the tables within the Almanac. So back to our problem in hand. When we have the angle of the sun above the horizon, from the Almanac we have the declination corresponding to the date. Our latitude is 90 degrees minus our measured angle plus the declination. As I said, we can measure the current time of the day. This obviously is an approximation. This particular astrolabe is not set up for this latitude in this area. But what we would need to do is to measure the angle of the sun above the horizon. So we're assuming we are going to be looking through here. We will line this up on the horizon. We would then look through there at the sun to measure that angle. Now we would need to record or note that angle. Now we need to set the date, which I have done some marking on here. This is April. So we need to measure around about April 15. So I'm going to use the ruler. That's April 5, 10, 15. And we will line that up with the main graticule at the top. Now this marks the position of the sun astronomically as it is at the moment. But of course our sun is in a different position. So what we'll do is move the rule round. And then we'll move everything else around so that the rule will line up with the Adelaide on the other side. So then we're lining up on the other side, and then that will read off the time. So 12, 11, 10, 9, around about, 8 o'clock? And that's how we would take the time.